All right, welcome back to the deep dive. Today we're tackling something that's pretty fundamental to, well, pretty much every piece of software out there. We're talking about variables.
Yeah, it might sound a little bit technical at first, but really, variables are essential to how everything from the apps on your phone to the websites you browse to even complex scientific simulations actually work.
If you think about it, understanding variables is kind of like getting a peek behind the curtain on how computers actually manage and manipulate all that information.
Totally. It's like one of those core building blocks of programming.
And to guide us through this deep dive, we've got some awesome material to work with.
Yeah, we dug up some transcripts from the Code Curious YouTube channel, specifically their videos on APCSP 3101 variables and assignments and APCSP 3101 variables and assignments, both featuring Dr. Mitchell.
She breaks things down really well. So our mission today is to unpack what variables are, how they get their names, what kind of information they can hold, and how those values can change over time.
And by the end of this, you'll have a much clearer picture of what's going on behind the scenes, those invisible processes that make software do its thing.
So let's start with the basics. In the world of programming, what exactly is a variable?
Well, Dr. Mitchell uses a really helpful analogy to explain this. She describes a variable as an abstraction in a program, something that holds a value. Think of it as a box.
Okay, a box, like a container.
Right, a container that exists inside the computer's memory and is ready to store different pieces of information.
Makes sense, but these boxes can't just be floating around without any way to identify them, right?
Exactly, you need a way to keep track of them. And that's where names come in, also called identifiers.
So each variable gets a unique name.
Precisely. And these names are super important because they allow the program to refer to the specific information stored in that box. So instead of the program needing to know, the exact memory location where the data is stored, it can simply use the variable's name.
Got it. It's like labeling those boxes so you know what's inside each one.
Exactly. It's all about organization and giving those pieces of data a meaningful way to be accessed.
So what kinds of things can you actually put into these metaphorical boxes?
Oh, they can hold a variety of things.
Yeah.
Dr. Mitchell gives a few key examples. First, you have numbers. If you wanted to keep track of the number of students in a class, you could have a variable named, let's say, num students.
Okay.
And it could hold the value, 10.
Simple enough. Like writing number of students on a box and putting a little card inside with the number 10 on it.
That's a great way to visualize it. Then you have what are called Boolean values. These are really important for decision-making in programs.
Decision-making.
Yeah, because they represent either true or false. So a variable like an isPassing could hold the value false if a student, hasn't met the requirements to pass a course, and true if they have.
Okay, so it's like a simple yes or no on or off switch.
Precisely. And then you have text, which programmers often call strings.
Strings, like words and sentences.
Exactly. A variable named welcome could hold the text, hello world.
Ah, the classic hello world. Every programmer's first program.
It's a tradition. So these variables allow programs to work with and display all kinds of textual information.
Okay, so whether it's a number, a true-false value, or some text, a variable gives us a way to refer to that piece of information by name. It's like a filing system for your program.
It's a really helpful way to think about it. Now let's talk a bit more about those names. Dr. Mitchell spends quite a bit of time explaining how to choose good variable names, and it's more important than it might seem at first.
Right. I remember her saying that choosing the right names makes your code much easier to understand and maintain.
It's all about clarity. If you come back to your code later or someone else needs to read it, good variable names will make everyone's life a lot easier.
So what were some of the good examples she gave? What makes for a strong variable name?
She mentioned that something like high score is good, it's concise.
Yeah, it's clear what kind of information that variable would hold.
Right. Similarly, first name clearly indicates that it's storing someone's first name. And is raining, that's a Boolean that would tell you about the weather. Even something like phone number is pretty straightforward.
Those also pretty intuitive. What about the bad examples? What should people try to avoid when naming their variables?
Well, one thing to avoid is names that are just way too long. Highest score in the current game session does technically convey meaning, but it's super cumbersome.
Yeah, imagine having to type that out every time you need to use that variable.
It would be a nightmare. Dr. Mitchell also mentioned that with longer names, you're way more likely to make typos.
And those typos can lead to all sorts of errors. What else? What about names that are too short and not descriptive enough.
That's another big one. Like a variable name like just N or X, you have no idea what that's supposed to represent.
Yeah, it's like labeling a box with just a scribble. Good luck figuring out what's in there later on.
You lose all that context. It's important to choose names that actually tell you something about the data they're holding.
Got it. It's not too long, not too short, and meaningful. What about the structure of the names? Are there any technical rules?
Yeah, there are. For example, you generally can't use spaces in variable names in most programming languages.
So you couldn't have something like player score with a space in between.
Right, that would usually cause an error. Instead, you would use something like player score all one word or player score with an underscore.
That makes sense. And what about starting a variable name with a number or using special characters like hyphens or asterisks?
Those are usually either discouraged or completely forbidden. Dr. Mitchell gave an example like 555 number.
Okay.
Starting a variable name with a number can confuse the program's interpreter, and special characters like the hyphen can lead to all sorts of problems as well.
So best to stick to letters,
Yeah.
numbers after the first letter, and underscores to keep things clear.
Exactly. Now, we've talked about the types of information variables can hold. Why is it so important to be aware of these different data types?
Because it affects what you can actually do with that information, right? Like you can do math with numbers, but not really with text.
That's exactly it. The data type determines the operations you can perform on that data. And it can also impact how efficiently your program runs and how much memory it uses.
So Dr. Mitchell talked about some of the most common data types, right? Like integers for storing whole numbers.
Yep. Integers are great for things like, a high score or someone's age where you're likely going to be doing some calculations.
And then strings for text, like someone's first name or a movie title.
Yeah.
But wait a minute, what about something like a student ID, which is usually made up of numbers? Would that be stored as a number?
That's a really good question, and actually a really important point to understand. Even if something looks like a number, if you're not going to be doing any math with it, it's often better to store it as a string.
Huh. So just because it's made up of digits doesn't necessarily mean it should be treated as a number in the programming world.
Exactly. Think about a phone number. You don't add two phone numbers together. You store them, you display them, maybe you search for them. So treating them as text makes more sense in that context.
And you avoid any potential weirdness if the program tries to accidentally do math with something like a phone number.
Exactly. And the same logic often applies to things like zip codes or ID numbers. And of course, we have Booleans for those true-false values.
Like, is ringing to track the weather, or maybe is logged in to see if a user is currently signed in to a website.
Exactly. Those Booleans are super important for controlling the flow of a program, deciding what actions to take based on whether certain conditions are met.
Okay, so we've got these named containers. They can hold different types of information, but how do we actually get the data into a variable in the first place? That's where assignment comes in, right?
Exactly. The process of storing a value into a variable is called assignment, and it's usually done using an assignment operator, which is just a fancy way of saying a symbol that tells the program to do the assigning.
Okay, and what's the symbol?
In most programming languages, it's just a single equal sign.
Okay, so it's like saying, take this value and put it into this container.
That's a great way to think about it.
Can you give us some examples of what that looks like, in code?
Sure. So if you wanted to store the value 100 in the high score variable, you'd write high score 100.
Right.
To store the name Ashley in the first name variable, you'd write first name Ashley.
Okay.
Notice the quotation marks around the text. That's how you usually indicate that it's a string. For a Boolean, you might have Sarah Raining, true.
All right.
And for a phone number, you could have phone number 555-0101, again with the quotation marks because we're treating it as text.
So you just use that equal sign to essentially link the variable name to a specific value. Makes sense. But what if you need to change that value later on in the program? Can you just assign a new value to the same variable?
Absolutely. That's
Yeah.
one of the key things about variables. Their values can vary. It's why they're called variables.
I see what you did there.
You can update the information stored in a variable at any time. Think of it like taking the old value out of the box and putting a new one in.
So it's not like a permanent label. You can change what's inside.
Exactly. And Dr. Mitchell had this really helpful example involving scores to illustrate this point.
Can you walk us through it?
Okay, imagine you have a variable called current score, and it starts with the value 10.
Okay.
And then at some point in the program, you want to store that score as the high score. So you would write high score, current score.
Okay, so now both variables have the value 10.
Right. But now let's say the player keeps playing and their current score increases to 15. So you update that variable, current score equal 15.
Okay.
But here's the key. Changing current score doesn't automatically update high score.
So it's not like those two variables are permanently linked. Assigning one variable to another is more like taking a snapshot of the value at that specific moment in time.
Precisely. If you wanted to also update high score, you'd have to explicitly reassign it, maybe with that new current score if it was actually higher.
So the key takeaway is that the last assignment made to a variable determines its current value.
Absolutely. And Dr. Mitchell walked through a couple of simple code examples to show how this works in practice. Want to take a look?
Yeah, let's break those down.
Okay. So in the first example, we start by assigning the value 4 to a variable called num1.
So our metaphorical box labeled num1 now has a 4 inside.
Exactly. Then we assign the value 6 to another variable, num2.
Okay, so another box, num2, gets a 6.
Right. And now comes the interesting part. The next line of code says num1 equals num2.
Uh-oh, things are about to change.
What this does is it takes the current value of num2, which is 6, and it assigns that value to num1.
So the 4 that was in num1 gets overwritten.
Exactly. Num1 now also holds the value 6.
So if we were to check the values of both variables at this point, they would both be 6.
That's right. The value from num2 got copied into num1, but the value in num2 itself remained the same.
All right, and then the second example had 3 variables, right? Things get a bit more complex there.
Yeah, a little more juggling of values. So we start by assigning 25 to num1, 15 to num2, and 30 to num3.
Got it. 3 boxes, 3 numbers.
The first instruction is num2, which is 30, gets assigned to num2, replacing the 15 that was there originally.
So now both num2 and num3 have the value 30.
Precisely. Then we have num3 equals num1. This takes the value of num1, which is 25, and puts it into num3, replacing the 30 that was there.
Okay, so now we have num1 with 25, num2 with 30, and num3 also with 25. One more assignment to go.
Right. And that last assignment is num1 equals num2. So the value in num2, which is 30, gets assigned to num1, replacing the 25 that was there.
All right, let's see if I can keep track. So at the very end, what are the final values stored in those 3 variables?
Num1 and num2 both end up with the value 30, and num3 ends up with the value 25.
That's pretty cool. It's like those values are dancing around between the variables.
It is kind of like a little dance of information.
All right, so let's recap the key takeaways from this deep dive into variables.
All right, hit me.
First off, variables are essential building blocks in programming. They're those named containers for holding information.
Right. Those containers allow programs to manage and access data in a structured way.
Secondly, choosing good, descriptive variable names is super important.
Totally. Clarity is key. No crazy long names, no single-letter mysteries.
Right, and avoid spaces and starting names with numbers or special characters.
Got it. Makes code way easier to read and work with.
Third, the data type of a variable matters. Integers, strings, booleans, knowing the data type tells you what you can do with that data.
And sometimes things that look like numbers might actually be better stored as text, depending on how you're going to be using them.
Right, like phone numbers. And finally, that assignment operator, usually an equal sign, is how we put values into variables.
And remember, assigning one variable to another is like making a copy of the value at that moment. Changes to one don't automatically affect the other unless you explicitly do another assignment.
And the last assignment made to a variable is the one that counts.
Absolutely.
So understanding these concepts gives you a fundamental understanding of how computers work with information, which is pretty much the foundation of all the technology we use every day.
Couldn't have said it better myself.
Now, here's a final thought to ponder as we wrap things up. How might this concept of variables holding and changing values be used to model real-world processes?
Ooh, I like that.
Think about the changing stock prices, the number of unread emails in your inbox, or the steps counted by your fitness tracker. These are all dynamic systems where information is constantly changing.
Those are great examples.
How could you use variables to represent and manipulate those kinds of data?
It's a fascinating question to consider. It really makes you start to see the world through a computational lens. Thanks for joining us for this deep dive into variables. It's been fun.
Until next time.